Good afternoon, ladies and gentlemen. I'm glad to be here to speak on the Gati Shakti, Revolutionizing India's digital infrastructure. I think most of the people in the audience will agree that 5G is perhaps the most important wireless technology that can help in India's digital infrastructure, particularly at the last mile. Right, so that's why today my topic here is basically to talk about how we can actually provide 5G indoors for the last mile connectivity in order to realize the digital infrastructure. Right, so basically we have seen many use cases in the last 2 days show, all right, and you can see that most of the use case basically falls into three main categories. Now the first is basically what we call the enhanced mobile broadband, which is EMBB for short. Now this use case basically focus on delivery of very, very high speed connections, right? So you can see examples of those use cases are in the what I've listed there, right? And the second important aspects of digital infrastructure is the massive IoT, right? I think the Internet of Things has been quite common. I think everybody knows what is the Internet of Things, right? And you can see that there are a number of use cases, right, that looks at the massive IoT. That means we have millions of devices connected to the 5G network. So this is actually part of the digital infrastructure. Now the third and perhaps the most important of the use case is the critical IoT use case, where we talk about the network being able to deliver ultra low latency, ultra reliable kind of a use case. Things like Industry 4.0, remote surgery, and things like that, right? Where latency, ultra low latency is very important. So these are the three key aspects of the use case, right, in terms of 5G. And you can see that on the left side, as we move to the left side, we look at basically focusing on low power consumption and low data rates, right? And on the other extreme end, we are looking at ultra reliable connectivity and very, very low latency, right? And of course, in the middle, we talk about having a very high data rate, right? So these are how the various use cases can be classified. Now, of course, if you look at all these use cases, you will see that most of these use cases are actually occurring inside the building, right? And of course, I can just highlight some of these important ones like connected healthcare, education, right? And hospitality, hotels, and of course, corporate headquarters and smart manufacturing, Industry 4.0, and of course, high capacity venues. These are some of the, perhaps the more important indoor connectivity use cases. Now, let's look at the key considerations to solve the challenges for 5G indoors. Now, you can see that in terms of the spectrum and use case for indoors, you can see that basically 5G can operate from less than 1 gigahertz up to maybe 100 gigahertz. All right, so if you look at each of the segment, it can be classified into three main categories. The low band, which is less than 1 gigahertz. So basically, these band can actually be served from outdoors because they are low frequency, they are able to penetrate into the buildings. But if you use these bands for 5G, you will find that ultra reliability and low latency is not supported well because the signals are basically from outdoor, right? And we look at the other extreme end on the high frequency band, right, which is basically the millimeter wave. We have another problem, okay? Although it's actually very good for very, very high data rates and ultra low latency, but the key issues in the millimeter wave is that the signals can only propagate very short distances. It is unable to penetrate through the walls, and therefore, using these bands, it is not suitable for ubiquitous coverage inside the building. So now we come on to the last band, which is the mid band, and mid band we have which is less than 6 gigahertz, and in the band of the less than 3 gigahertz is where we have our existing 4G spectrum, right, in the 1800, in the 2100, and so on. But these bands basically, while they are good, but they do not have sufficient bandwidth to implement eMBB in 5G. And that's why we are focusing on the new band, which is in the more than 3 gigahertz, about the 4 gigahertz band, which is actually the new band that's allocated for 5G. And this is the band that will actually be able to give you good coverage and be able to deliver eMBB applications, ultra low latency, and all the requirements of 5G. All right, so just one slide to talk about what are the key technologies in 5G that's able to deliver these enhanced mobile broadband throughputs. Right, we look at something called high order modulation. Some of you may know about 256 QAM modulation because you buy Wi-Fi 6, it supports 256 QAM modulation. So basically what is all this modulation is that the higher the order you go, you can actually transmit more data. But there's a catch to it, nothing is for free, right? You want more speed, there is a price to pay for, and that is signal to noise ratio. The wanted signal has to be sufficiently strong compared to the interference and noise in the network, right? So we are looking at something like 30 dB. That means the wanted signal must be 1,000 times stronger in power as compared to the interference in the network. This is the kind of signal to noise ratio that the network has to deliver in order to get the maximum speed from the 5G network. And of course, the second aspect, which is related to the first, is how do we manage interference in the network? Right, we have to try to minimize interference in order to maximize the SNR. Right, so the two are related. And third, of course, is also something which I think some of you may have heard of, MIMO. So what is MIMO? It is basically talking about transmitting multiple data streams on the same bandwidth. So for example, you can see the data there. If we have 4 data streams, and each data stream occupying 100 megahertz of bandwidth, then you can get a maximum throughput of about 1.5 Gbps on a 5G network. So MIMO is very important, but the network has to provide 4 data streams in order to be able to support MIMO. And lastly, we talk about this term called dual connectivity and dynamic spectrum sharing. Basically, this relates to the interworking between 5G and 4G. But as you know, in 5G, because the frequency band is higher, the losses are higher, and you might not get ubiquitous coverage. So when 5G runs out of coverage, the system will fall back to 4G to supplement. So therefore, there's a close interworking between 5G and 4G in order to realize the speed that you want. So these are the 4 key technologies that actually help 5G to be able to deliver the speed that you need. Right, and now we look at the deployment options. How can we bring 5G inside the building, right? Of course, I think traditionally we have been using what we call a passive infrastructure. I think 99.99% of the DAS in India is implemented on a passive infrastructure. So the problem with a passive infrastructure is that it is unable to support the new bands at 3.5 gigahertz, right? Because of the high losses in the passive infrastructure. And of course, it's also difficult to support 4x4 MIMO that will actually determine the speed of a 5G network. And that's why we are moving into small cells, which I think the previous speaker has spoken about small cells. Right, so of course, small cells is good, right? It has its own pros and cons, right? It is basically supporting single operator and maybe maximum 2 operators on a small cell architecture. And it basically is only suitable for small to medium-sized venues, right? If you have got a very large venue with multi-operator, multi-band, then using a small cell solution to provide indoor for 5G would be expensive. And lastly would be what we call the active DAS, right? Which is basically a low-power solution, right? It is supporting 4 operators for 5G, right? And also able to support 4G on the same remote unit, all right? And the end-to-end connectivity is basically a fiber, which allows us to transmit something like more than 1,800 megahertz of RF bandwidth in a single box. So that will be able to deliver the speeds that you want for 4 operators with 5G and 4G, all right? And of course, It's so able to provide maximum capacity to all the remote units. Of course, latency, less than 1 microseconds. Right, so that will allow you to be able to implement all use case for critical IoT within the building, right? And basically, also, it supports integration to the upcoming Open RAN standards, right? So we can actually interface directly to the what we call the distribution unit of the Open RAN without the use of a high-power remote unit. And basically, the active DAS is suitable for high-capacity, large venues with a multi-operator environment. So what about Wi-Fi? I think maybe some of you may have a question. Why can't Wi-Fi be used as the last mile connectivity? We have Wi-Fi 6 and now Wi-Fi 7. So why is it that Wi-Fi is unable to fulfill this function? Right? There are 3 aspects in terms of reliability and critical low latency requirements. Now, as we know, Wi-Fi operates only in the unlicensed band, the 2.4 gig and the 5 gig. And operating in unlicensed bands means it's prone to interference from other devices that are also operating the same band. And therefore, you are unable to guarantee the ultra reliability and critical low latency requirements, right? And in Wi-Fi, we have this QoS called the best effort. That means the network will try its best to deliver the data, but there is no guarantee that the data will be delivered successfully. So this is what Wi-Fi can deliver. Whereas in 5G, it has a full set of QoS, right, to be able to deliver all types of data, whether it's eMBB data, massive IoT data, or ultra-critical IoT data. They will give priority for critical IoT because it is critical. You need ultra-low latency. So 5G has the full suite of QoS requirements to meet all the requirements for digital infrastructure. The second one is on mobility and outdoor. Now, Wi-Fi typically is only deployed for indoors. It is not so suitable for use in outdoor. Whereas 5G, it is actually will give you ubiquitous coverage from indoor to outdoor. And lastly, security. Now, I think security is a very important aspect. Now, I think everybody knows that Wi-Fi security is not as good. It is limited to within the building, within the house. But certainly, it is not as secure as a 5G network. Now, imagine, we are talking about Industry 4.0, where the 5G network is used to control robots. Imagine someone hacks into the system and control your robot to destruct your factory. That will be a major disaster. And that's why security is a very important function in 5G, because the 5G network can deliver ultra-low latency to the extent that it can control robots, which can be destructive to the human race if a hacker is able to access it. And that's why security in 5G is so important. Right? So in summary, Wi-Fi is suitable for indoor use cases where reliable, ultra-low latency and predictable connections is not required. So this is where Wi-Fi 6 stands different from 5G. Now, my last slide, in summary, I think we spoke about data rates being increasing by several folds, in fact, 10 folds or more, and that more customers are demanding things like 4K video, virtual reality, augmented reality, right? And 5G technology is the key enabler of IoT in smart buildings and digital infrastructure. And this puts a strong call for 5G indoors because, as we can see, most of the critical applications occur inside the building. And active DAS and small cells are perhaps the 2 most important deployment options to bring 5G into the indoor environment. Right? Each has its own pros and cons, right? And there's actually no one solution that fits all. If you have a small building, perhaps a small cell is preferred. But if you've got a big building with multi-operators, then perhaps an active DAS is preferred. Right? And 5G will have to coexist with existing 4G. because of the higher bands that they operate, you are unable to ensure ubiquitous coverage, and therefore 4G is still needed as a backup platform to support 5G. Right, so with that, I finish with my presentation today. Thank you for your time and attention.